Okay, so conduction and convection are actually triple topics. However, I've decided to include them in here because I think it will help us to understand the following concepts afterwards. So first of all, what is conduction? Conduction is, you can think of it as a Mexican wave of energy going through a material. So the side that heat gets heated up first, that area, the particles will gain kinetic energy, they will begin to vibrate and collide with the neighboring particles. And by colliding, they will pass their energy to them. And then this keeps on happening throughout the material until energy is transferred all the way to the other side. So this is the definition for conduction. Okay, now remember, conduction happens best in solids, and the reason is because particles are closer together. However, in liquids and gases, you can say conduction hardly ever happens, and especially in gases, it's the least conductive. Now, when you're cooking, of course, you want to use a wooden spoon, and the reason behind that is although metal and wood are both solids, making them conductors, metal is actually a better conductor of heat than wood. And the reason behind that is not only because the particles are close together, obviously because it has metallic bonding, but also because it has electrons, and then those electrons can help to transfer the energy much more quickly. Wood, on the other hand, is an insulating material because although, again, it's a solid, however, there are air spaces between the particles, making it have low thermal conductivity. Convection, again, only happens in liquids and gases. It does not happen in solids because for convection you need moving particles. So the way it works is this. A liquid or a gas is heated up. When it gets heated, the gas particles or liquid particles gain energy, they move apart from one another and become less dense. As they become less dense, they start to move up. And now as they move up, there's already liquid or gas up here. So what they do is they displace them, meaning they push them down. So that cold liquid at the top gets pushed down and then it gets heated up again. And then the cycle continues, and this continuing cycle of heat is known as a convection current. Again, so convection only happens in liquid and gases. So the gas particles gain energy, they move faster, they move apart, become less dense and rise, and displaces the cooler gas or liquid from the top. Now, if you look at this picture was taken using an infrared scope or an infrared camera, and it shows us the different parts of the house and where energy is lost the most. So you can see over here, for example, in the roof and in the windows, there's a lot of energy loss, a lot of heat loss. So how can we reduce that? Now, normally, if you have a solid, having a single wall that's basically a solid. Now, through solids, heat is lost via conduction. However, how you could improve that is by having two walls. Now, if you have two walls, again, in between the two walls, you'll have empty space, which is basically full of air. So what's going to happen is heat's going to go through the wall via conduction, and then when it gets to the air part, it's going to move via convection. And this takes much more longer. Because it takes longer, that means that the heat remains inside the house for a longer period of time. Therefore, there's less heat being lost. So wall cavity, less conduction. Now, you can actually fill up that wall cavity with foam, and it'll look something like this. Now, the reason we do that is because although we know there's convection happening here, we can reduce that as well by having this cavity wall insulation. So now, having two walls and also filling up the airspace means there's also going to be less convection happening here. So again, that's even better if you want to keep the house warm for longer. Okay, double glazed windows. So you have one window pane. Remember, this is a solid. And then you have another window pane, and between them there's an airspace. So very similar to the two walls with air in the middle. Now this again helps to reduce conduction because you have two walls, two windows instead of having one solid. Why you wouldn't fill up the area in between is because although you could fill it up just like the cavity wall insulation, but the point of a window is for you to be able to see outside. If you fill it up with foam, then although it might be better at keeping heat in the house, it's not going to be a window anymore. Okay, draw excluders. What these guys do is, think about this. Hot air sometimes can leave under the doors. Now, to prevent that, is what you can do is put a foam roll underneath the door, and what this foam roll will do is it will prevent the hot air from escaping. This is known as a draw excluder. And this is a cap. Now, this table shows all the different types of ways that you can prevent heat from being lost from your house, and also how they do that. For example, conduction, convection, etc. So make sure you memorize all of these words because it could be easy 1 or 2 markers. Okay, efficiency. So any device, any electrical device, for example, a phone, a laptop, even let's say a crane or any machine that takes in energy, will also give out energy. Now, the way it gives out energy is that it can give it out in useful forms or as waste. So, for example, and of course, this will depend on every machine. Now, let's look at this phone. It takes in 100 joules of electrical energy. It gives out 30 joules of light and 10 joules of sound. Also, the rest of it is giving out as heat. So one of the rules is that you have to make sure that energy in is equal to energy out. So 100 in, 100 out. However, we can see that the device has transformed the energy. Now, from these three, we know that light and sound are useful because we have to use light has to come out so you can see your phone, and sound so that you can hear whatever you're listening to. Whereas thermal is a waste energy. You don't use your phone to heat up your hand or to keep you warm. So that's a waste energy. Now, if you were to calculate efficiency, that would be useful divided by total input. So in this case, it'll be 40 over 100. Now, you can leave it as a decimal or you can times it by 100 to give it to you as a percentage. Now, friction, in most moving objects, friction is the reason why there's a lot of energy being lost, because friction leads to heat, and heat is a waste energy in most scenarios, except for things like radiators, where it's not a waste energy because you want to use a radiator to get warm. So how you can reduce friction is by using lubrication. This will reduce friction, so if there's less friction, there'll be less heat energy being lost, and therefore there'll be higher efficiency. So your machines will have higher efficiency.
Hey guys, if that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at ExamQA.com, where I will personally be there to help answer your questions. Mohammed signing out.